Hello, it's Duncan. We're taking another little break from Gilded Rose this week to look at software design, and in particular domain modelling, how we represent aspects of the real world in our software. The domain that I've chosen is 10-pin bowling. There is a bowling kata, but that's only concerned with the scoring of a game, and I'm more interested in the game state, the progression of a game, whose turn it is, when it ends, etc. As an experiment, instead of test-driven design, I'm going to see how far we can get with type-driven design. We're going to start by identifying the types of things that we see in the domain, players, frames, pins and so on, and see how we can model those in Kotlin types. Then we'll look at the relationship between those types, again expressing them in Kotlin code. Finally, we look at the operations that those types support. Types can guide us here too, suggesting implementations based on how we can derive an output type from the input types. By the end, we have a reasonably complete Kotlin model of the domain, some method definitions, and some to-dos, where I really don't feel comfortable guessing at an implementation without writing some tests. Usually I'm all about the tests, but today as an experiment we're going to leave off writing the tests for as long as we can and concentrate on the types. And I'm going to look for those types and their relationships in this WikiHow page of how to score bowling. We'll actually think about scoring later on. For now we'll just concentrate on whose turn it is, when a ball is rolled, who gets that score. And types are often nouns, so we're going to go looking for nouns in here. Given that we set ourselves the task of tracking the progress of a game in software, but when there is no software you can track progress on this scorecard, I think maybe the scorecard is a good place to start. Let's have a look at what we see in a scorecard. A scorecard represents a game, so maybe a game is a thing. I'm going to write that down and come back to it. There are evidently players. The player has a name. There are these things here. These represent frames. Each frame has a score that we'll write into here. And that score is composed from these pin counts. I'm going to call them pin count. It's the number that we write into these little boxes. Each frame consists of up to 2 rolls. Only 1 roll if you knock down all the pins. Except for the final frame here where there may be up to 3 rolls if you scored a strike in the 9th frame. And one more thing that I haven't really found a name for, but it is the game for this player. So it's this line on the scorecard. So I'm going to call that line. Other things may come up, but let's start with these and write them down in code. So our candidates for types at the moment are game, player, player name, frame, score, pin count and line. And in Kotlin at least, the default thing that we have to represent a type is a class. So I'm just going to write class, game, class player, class player name, class frame, there's a score, a pin count, and a line. Okay, so these are some of the types. Now what we're going to do is see how much we can express about a game of bowling in the types. So, for example, this is 10-pin bowling, so our pin count is expressing the number of pins that have fallen over, and that can never be more than 10 because there can never have been more than 10 pins in the lane. It can also never be negative because you can't have a negative number of bits of wood. So a pin count encapsulates a number of pins, so we'll just call that our value, which is an integer. And we can say in our init that we require that value is greater than or equal to 0 and value is less than or equal to 10. And IntelliJ suggests that we convert that to a range check like that. So that's not a relationship between types, but it's a constraint on a type. And because this only has one value inside it, we can make it a value class. Like that. And I can't bear for IntelliJ to moan at me, so I'm just going to change that to a capital C. There we go. Now we can apply the same thinking to the score. It has a value, which has to be an integer. And in a standard bowling game, the score can't be negative. And it can't be more than 300, I think. So I'm going to put 300 in here. And again, this can be a value class. There we go. And in this case, we're using the value class to indicate that our score and our pin count are just constraining an integer value. Okay, then now let's look at some of the relationships between types. Let's go back to the web page. Okay, we're using this scorecard to represent a game, or the game to represent a scorecard. So I think we can say that a game has a list of lines. So that's a list of line. And we'll come back later to how that happens. Don't know what a player is yet. A player name, well, we're just going to write that in here. So I think maybe it's just really a string. But again, we'll wrap up that string so we know that we're talking about a player name. So we'll say this has a value that's a string. And we'll make it a value class. Now we could say that player names can't be empty, but I'm not sure that's helpful at the moment, so we'll just leave this as it is. Okay, don't know about a frame, but if we move a line up from here, I think a line has a list of frames. Whatever a frame is, and we will say, don't know quite how to do that yet, but it also has a player name, because that's what we're going to write in here. Good. Looking down the web page, as we bowl, then pin counts get added to frames here. And there's a strike, so there's only one pin count. There's a spare, foul, miss, but here's a score. And so a frame has 2 pin counts, or up to 2 pin counts, and a score, but it may not have a score if it hasn't been played yet. Well, let's pencil those into frames, shall we? So let's say that a frame has a roll 1 that is a pin count that might not be there, so it's nullable. And it has a roll 2 that again might not be there. And there's a final frame, that's the one that might have 3 rolls. I think I'm just going to punt on that for now. And then finally a frame has a score, which is a score that might not be there, and we'll work out later. And while we whiz down there, there are a few little details there. There was a miss. Well, I guess that's just a score of 0, so that's okay. But there's also a foul. I think I'm just going to write that in and worry about it later. So we'll say there's something that is a foul. Okay then, I'm just going to take player, which is currently, we don't really know what to do, and move that down the bottom along with foul, so that we can see what we've got. So, if it's on one screen, we've got a game which is composed of lines. We've got lines which has a player name and some frames. A player name is just a wrapper on a string. A frame we know has a roll 1, a roll 2, maybe a roll 3 at the end, and maybe a score. A score is a wrapper on an int, and a pin count is a wrapper on an int, where we're using the wrappers to enforce the range. So far this is entirely a data-oriented view of a bowling game. I think that might be a good place to commit, so let's do that with sketch out the data. Lots of to-dos that we can't really care about, and back here. Now then, let's start thinking about operations. What I'd like to be able to do is to pass the number of pins that have just fallen down to a game and have it assign those pins to the right frame and hits the right line and hits the right player. So the game in some sort of way is going to have to keep track of whose turn it is. But what should a game do when all the players are finished? It could signal an error by throwing an exception from our roll, but it would be better if there simply wasn't a roll method to invoke when the game was finished. How could we manage that? Well, we could have 2 types of game, a playable game and a completed game. Let's sketch that out here. In order to have 2 types of game, I'm going to make game an interface. And because at the moment we believe there's only 2 types of game, we'll make this a sealed interface. And being an interface, we don't have to give this an implementation. Given that then, we can have a class completed game, which is a game, and it would need to implement the lines. That would do for now. And we can also have a class, I think we'll call it playable game, which is also a game. And must therefore also implement lines. But playable game is the thing that's going to have our roll operation. So this is going to have a method, which is fun, roll, and this is going to take a pin count. And IntelliJ is saying we need to tell it the return type. Now, that's an interesting question. It's easy to think of roll as something that mutates our playable game, So this will just return unit. But if we're just mutating our playable game, it will always be a playable game. We can't change its type. If we want to change it to a completed game in the end, it itself needs to return a game. A different object that represents the next state on, the one that accounts for this role on top of this game. So with some trepidation, because I really, really want to write a test, I'm going to sketch out what this method is going to do. It is going to say, find the current line, which is going to be a line. Don't know how to do that yet. And in the same way as role on a game returns another game, it's going to get a new line by passing the pin count to the current line. Well, I suppose that means that we know we need a role, so let's create that. And we also know that needs to return line. There we go. And now back up here. Let's put the types in here so we remember. This is going to be a line. Now we need a new lines collection. So we'll say val new lines. That's going to be our current lines, which is this val. And we want to replace the current line with the new line. That doesn't actually exist either at the moment, so let's pretend that exists by creating an extension function like that. And this is going to return list of E, in order that this can return list of line. Now, is the game finished? Well, we don't know, but we might be able to ask the new lines. So we could say that if new lines has a playable line, then we want to return, well, that will still be a playable game. So this is playable game with the new lines. Else we are going to return a completed game with the new lines. A few things need to exist for this to be true. First of all, we need a constructor for playable game and completed game that takes lines. Well, I guess IntelliJ will do that for us. So we're going to add a parameter to the constructor. I guess we'll just let that happen, and we'll do the same here. And now if we make this val lines, which needs to be override, then we can get rid of that. And same is true here. Make it a val override the one in game and get rid of that. So now completed game and game are our data, and I think probably we could make them data classes. What about new lines has a playable line? Don't know how to do that yet, so let's just create ourselves an extension on list, returns Boolean, and we don't know how to do yet. But this is going to be a list of line like that. I'm going to move these out of the way. Still not writing any tests, still just following the types. So let's put those down there to be done later. Come back up, and now we can see that we can start with a playable game, roll giving us another playable game, roll on that giving us another playable game, until eventually the playable game isn't playable anymore and it's a completed game, and then there will be no roll on completed game. So I'm just going to turn these upside down so we can see the flow. I so want to run the tests right now, but I don't have any tests. Let's keep on following the types. How do you implement new lines has a playable line? Well, one way we could do that would be if a playable line and a normal line were different types. In that case, new lines has a playable line. Let's inline it into here. Not very helpfully. Let's write it ourselves. Let's say val game is still playable. We could say new lines any it, which is a line, is playable line. Now, that's a type we don't yet have. Let's see what happens if we create it. We're going to put it in here, and IntelliJ hasn't been clever enough to see that that must be a line in the scheme of things to make this compile. Still doesn't quite compile. I'm just going to fix this bit first. So if the game is still playable, we'll return a playable game. we're having a problem here with the type of line. Let's move this down here, and let's say that we'll pull the same stunt as we pulled with game, which is to say we'll have a sealed interface for line. We know every line, whether it's playable or not, we want to have a player name, so let's cut that out of there and put that into there. But again, don't need a to-do because it will be abstract. And every line will also have a list of frames, whether it's playable or not, because we need to be able to see the score of a completed game. So that's like that. Now then, we have a playable line implements line, and let's say completed line implements line, but obviously roll can only ever actually happen on a playable line. Okay, some issue with compiling, let's see. So playable line needs both a player name and frames, but we can implement those as a constructor parameter, like that. And likewise completed line. Okay, now we have more information. We can see that current line here actually has to be a playable line in order that we can call roll on it. That's good. But now we have the idea of a completed line. I think probably it's true that a completed game has to be a list of completed lines, like that. Can we be clever and get this to compile? Well, I think we probably could if we said that we had a val in here, which is completed lines, and that's lines filter is instance completed line. Now the type of that will be a list of completed lines. So we can use completed lines in here, and the game is playable if completed lines size is fewer than the number of lines in the game. I feel a little unsure about this comparison. I might have got it wrong. We're going to need to test eventually to check that that works. But in terms of the types, that's working quite well. And I think we could probably just inline that into there, pull this return out. And again, I really want to run the tests, but I don't have any tests to run. Let's close that up. Okay, I'm just going to close these up a bit for now, in order that we see what we're going to do when we roll on a playable line. Let's just go down and fetch frame, which at the moment is just a class. When we roll on a playable line, which frame is going to get the pin count? Well, we're going to do the same sort of thing. We're going to say current frame, which is going to be a frame, is something we don't know how to do yet. But once we've got that, we can say new frame is the current frame transformed by rolling the pin count. And we know this new frame also has to be a frame. Now, as up above, our new frames, which wants to be a list of frame, is our current frames, which is the frames, replacing the current frame with the new frame. And now the same logic as above, we have something that says is completed, which is a Boolean that we'll come back to. We can say return if it's completed. Now we're going to return a completed line with our player name and our new frames. Else, we're going to return a playable line with our player name and new frames. And now we can do the same thing with frame as we did with line. We can say, in fact, maybe frame should be an interface, in which case these operations are all just abstract. And now we can have a class for playable frame, which is a frame, but as constructor parameters for the data, and a class for completed frame, which looks much the same. But now we know here when we're finding the current frame, that needs to be a playable frame. And so only playable frame needs a role. So we're going to create a member function playable frame role, which is there. And again, this is going to return a frame that's a result of adding another role to our current frame. Okay, I think we may be getting close to the point where I need to write some tests, but not quite maybe. because I think we may have another state machine around playable frame. The first one, sketch it out here, is an unplayed frame. Now an unplayed frame will be a frame. And let's implement the members, do them all in one go. What do we know? Well, we know that unplayed frame doesn't have a role 1, so its role 1 must be null. Similarly, role 2 is null, and a score, well, it can't have one of those either, so that's going to be null. But we do want to put a role on an unplayed frame, so I think unplayed frame is a playable frame, and therefore probably we should make playable frame itself an interface. So let's say that interface playable frame, we're not going to do any of those things, but we're going to say playable frame is a frame that has a role that returns a frame. So our unplayed frame is playable, which means we need to implement role. What should unplayed frame transition to? Well, that depends on the pin count. So I think we could say here return when. Now if our pin count is 10, then that's a strike, and a strike isn't itself playable, so we're going to return a strike from this. A strike doesn't exist, so let's make it happen. Create a class strike in here. There it is. And strike is a frame, but it's not a playable frame. You can't throw any more balls at a strike, so let's implement the members. A strike has only role 1, which is a pin count, and that is going to be a pin count of 10 by definition. Its role 2, well, it's never going to have one. So the second role is going to be null. And its score, well, I'm really not sure about scores at the moment, so I'm going to leave that as a TODO. Okay then. So when pin count dot value is 10, that's a strike. Otherwise, well, we can roll another ball. So this is going to be an in progress frame, I think. And an in progress frame is going to want to remember its first roll, so that's the pin count. Okay, what's an in progress frame? Let's create a class for that. In here, there is one. It is a frame, but it's also a playable frame. Okay, now the thing that we pass to the constructor of in progress frame is going to be its role 1. So let's say this is val role 1, and that we need to override because it's in our parent. Let's add in the rest of things as members. So we've got role 2, score, and role. Let's deal with role 2 first. An in progress frame hasn't had a second role, so this is null. Scores we're just leaving as to do, that's fine. And when we roll on an in progress frame, unless it's the very last frame where it could have 3 rolls, an in progress frame is going to go straight to a completed frame. Here this is going to return completed frame. Now we've already got a type for that, called it complete frame, not completed. We will get around to fixing that in a moment. And the completed frame's role 1 is going to be our role 1. And its role 2 is going to be the pin count that has been applied to this in progress frame. The score I don't think should be part of the constructor for complete frame, so we can get rid of that. And that will force us to implement score, and we can leave that as a to-do. A couple of things we do know though is that in a complete frame we must have a role 1, so that's not null, and we must have a role 2, that's not null. And that's because there is another type of completed frame which only has one role, and that's strike. So this is maybe normal completed frame as opposed to a strike. Okay, before we review, I think we could tidy up a bit by moving this implementation of score up into our frame here. So we can say that's the default implementation is just to do in our frame. That means that we can get rid of that, and we don't have that on in progress frame because we just cut it out of there, and it's in strike, and it's in normal completed frame, and we will just put those on separate lines. Okay then, I'm going to tidy on my way to the top. So on my way to the top, we'll move that up there. We'll make this an expression, get rid of that. We will move roll down, and make it an expression. Unplayed frame is as yet unused. Note, we have playable frame that has role. We have every frame has a role 1, a role 2, and a score. Completed line doesn't need that. Drop those onto their own lines. And as we go up, we see we've got a few to-dos. So we don't know when a playable line is completed, although I think the answer is probably, as with a completed game, it's whether it has any frames that are playable. So we might sketch that in as playable frames, which is a list of playable frame, is frames filter is instance playable frame, and we're completed if our playable frames is empty. And we can inline that. Looking up here, we have a sort of asymmetry. Here we're finding completed lines, but here we're finding playable frames. We're doing that here because a completed game should consist of completed lines. And I suppose it's probably true that a completed line should consist of completed frames, but we don't actually have an interface for that. Maybe we should add it, in which case we can say that we have interface completed frame is a frame, and this is just a marker, and we can say that a strike is a completed frame, and a normal completed frame is a completed frame, and that would allow us to go back up here and say that we want to make this completed frames, which is a list of completed frame. That's completed frame, and now we'd have the same test here, which is that if the completed frames dot size is less than the frames dot size, then in that case we're a playable line, else we're a completed line, where the completed line can take the completed frames, and we go here and say that this must be a list of completed frame. Okay then, drop that down there, get rid of that, add that in there, and I think we can see a pattern in the state machines there. We've got two to-dos here that we need to write some logic for. We've written some code here that I think requires a test. And what else do we have? Well, actually, very little extra logic, which isn't really just part of the domain. There's a warning there. And finally, we have a to-do here in this replace, because we haven't written that. Score is entirely to-do, really, and player and foul we haven't yet found a use for. We can sometimes check the model with this diagram, which is generated from the code, although it took an awful lot of laying out. Here you can see that a game is an interface and will give us a list of lines. And games are two types. They're either a playable game, in which case we can roll on them, or it's a completed game, in which case we can't roll. Lines, well, they're a list of frames and have a player name, and they in turn are either playable or completed. If they're playable, you can roll, and if they're completed, you can't. And if they're completed also, the frames must all be completed. And a frame, well, that has a score we don't really know what to do with, and consists of two rolls, although the diagram has them in various orders, where each roll is optional. You can roll on a playable frame, and playable frames are either unplayed, in which case they have no pin counts but you can roll, or in progress, in which case they have one pin count and you can still roll. Completed frames are either a strike or a normal completed frame. Looking at this, I'm not sure how useful it would be to have roll 1 and roll 2 in the frame, especially as for the final frame there may be a roll 3. It may be better to say that in general a frame has no rolls, an unplayed frame has no rolls, but an in-progress frame has one roll, a strike 1 and a normal completed frame 2. I don't know yet. Let's see how well it works when we come to actually use this model. So as I say, as a test-driven developer, this is way more code than I'm comfortable having written without tests. But this is an experiment. So the aim is to see, for a domain like this that feels tractable for analysis, how far we can get without tests, just deducing things from the types and their relationships. Really see just how useful this is as a technique. So I think we'll check it in here with sketch out relationships and operations. Quite a lot of to-dos, I guess, unused things, unreachable code. So we'll just let that go, ready for the next episode, where we'll actually take this data model and exercise it by writing some tests. If you'd like to see that episode, then please subscribe to the channel, like this video so that other people can find it. And if you want to find more episodes like this, you could buy the book that I wrote in that price called Java to Kotlin, a Refactoring Guidebook, details of which are in the show notes below. Thanks for watching.